Sir, shall we wait another 2 minutes? Or
Yeah, Muthukumar, now, okay. Now I am comfortable, right?
okay, sir.
Shall
Okay.
I share the screen?
1 minute, sir. We will introduce. Then after that.
Yeah. Please. Okay. Yeah.
Very good afternoon to all the participants. Our today's guest of honor, Dr. M. Sudhakaran sir, Professor, Puducherry Technological University, Puducherry, India. Today we are going to have the session on Introduction to Modern Power System Operation Control and Resilience. Now, I request Mr. B. Mohan to introduce our
Sudhakaran sir is currently working as a professor in Department of Electrical and Electronics Engineering and has 23 years of experience in the field of research and teaching. And sir completed his B in 1997 and ME in 1998, and sir completed PhD in 2004 in the area of power system operation and control from Madurai Kamaraj University. Sir has published 44 international and national journals and 57 international and national conference papers. Under his guidance, 6 PhD scholars completed their PhD, and presently 4 PhD scholars are working. He is a board of studies member for Pondicherry University, Puducherry Technological University, and also working for various engineering colleges. And sir is a doctoral committee member for PhD research scholars in university like Anna University, Annamalai University, and also for VIT and SRM universities. He visited Germany, France, Netherlands, and Sri Lanka and United Arab Emirates for attending and presenting research findings in international conferences. He received Career Award for Young Teacher from Ministry of Human Resource Development, Government of India for the period 2012 to 15, and Young Engineer Award 2007 from Energy Society of India. He is a recipient of Best Journal Paper Award from Journal of Institution of Engineers India. He was the coordinator for many national level seminars sponsored by AICTE, DST, CSIR, and Institution of Engineers India. He is a technical consultant for the companies like Numeric Power Systems, Pondicherry, and Consol Power Systems, Chennai. He is one of the nodal officers for RUSA, Rashtriya Uchchatar Shiksha Abhiyan, project sponsored by MHRD, Government of India. Thank you, sir.
Thank you, Mohan. Yeah, Muthukumar. Yeah, can I share
Sir, now,
the slide?
yes, sir. You can share the slide. You can take over the everything, sir. Thank you.
Okay. Now, is it visible? Yeah.
Sir, visible, sir.
Yeah. Yes. Okay. Yeah. Yeah. Thank you very much. So, before starting my lecture, so a very good afternoon to all the organizers of this program and the participants, faculty members, non-teaching staff of VR Siddhartha Engineering College. And my special thanks to Dr. Muthukumar and Mr. Mohan Bukaya for giving me for giving about me a nice introduction for all the audiences. And moreover, before starting my lecture, the primary objective of this lecture is I want to make the audience understand about what do you mean by modern power system configuration. So Indian power system configuration, you should understand first. Then how the power system, Indian power system is operating. Then how the control of modern power system can be done. And at last, my objective is I want to introduce the new terminology in the power system operation and control called power system resilience. So the coherence of presentation will be the initially before going through the topics, I want to make the audience understand what is the status of the Indian electricity sector as on today. What is the status of Indian electricity sector? Then the electricity scenario in Tamil Nadu and Puducherry, where my institute is located. Then we want to discuss about the generators and loads. Then the main important topics like grid components, grid configuration, grid operation, and grid resilience. These four important topics will be discussed in detail. So this is the coherence of my presentation. So for the sake of comfortability, I want to mute my video for quite some time. Then in the intermediate time, I will unmute it, right? Okay. Now, so that the presentation will be easier and more comfortable for me, right? So this is the coherence of the slides available in the presentation. And as far as the Indian electricity sector is considered, the total installed capacity of power generation in our country as on 31st January 2022 will be roughly around 4 lakh megawatt. Okay, that is 4 gigawatt. And so this much installed capacity, this is the single largest capacity, installed capacity of electricity generation all over the world. So India has the single largest installed capacity of power generation, 4 lakh megawatt of installed capacity of electricity generation. Right. Now, before 2013, December 31st, there are two scenarios. Before December 31st, 2013, our country has two different frequencies inside the territory. Whereas after December 31st, 2013, we are having one nation, one grid, one frequency. First, you should understand our country has 5 regional grids in the territory. Southern grid, northern grid, western grid, eastern grid, northeastern grid. There are 5 regional grids in the country. Still, we are having 5 regional grids in the country, right? All the 5 regional grids, among the 5 regional grids, till December 31st, 2013, new grid means northern, eastern, western, northeastern. These 4 grids were integrated together, and it was called new grid. And the southern grid was actually separate, but it was linked by a very smaller capacity link. Okay, Power Grid Corporation of India's link. Okay, for transfer of electricity from southern grid to new grid or new grid to southern grid. So new grid means northern grid. N stands for northern grid, E stands for eastern, W stands for western grid, and NE, the first NE stands for northeastern grid. So these 4 grids were already integrated even before 2010, and it was called new grid. There was a very good coordination among the 4 grids in the new grid, okay, because of the larger capacity power evacuation facilities between each and every grid, except the southern grid I am talking. So southern grid was separate, the new grid was separate, 4 grids were separate, and the last 5th grid, southern regional grid, was separate. What is southern regional grid? Tamil Nadu, Puducherry, Kerala, Karnataka, Andhra. Okay, these states were the part of southern regional grid, and between these 2 grids, new grid and southern regional grid, the power evacuation facility was very least. So it was not possible to maintain single frequency in our country till December 31st, 2013. On December 31st, 2013, we have completed the process of complete integration of all the 5 regional grids. All the 5 regional grids on December 31st, 2013. And after that, 2013 onwards, that is 2013, we have realized here one nation, one grid, one frequency. Okay, right. Now, 5 regional grids I told you, and we are having a entity or organization called Power Grid Corporation of India in our country. Originally, the purpose of Power Grid Corporation of India is we wanted to have a control over the interstate power transmission, because our country is made up of so many states and union territories, and each and every state will have their own culture, their own consumption capacity, consumption attitude. So we want to have a controlling entity. That controlling entity is called Power Grid Corporation of India. So originally in 1989, it was in the name of National Power Transmission Corporation Limited. That is the original name of the Power Grid Corporation of India, National Power Transmission Corporation. So purpose is we want to have a control over the generated power and interstate power transfer. In 1992, we have renamed the organization name as Power Grid Corporation of India. In 1997, the company was promoted as Miniratna Company. In 2007, it was upgraded as Navaratna Company. And in 2019, it was one of the Maharatna companies in our country. 10 companies are available, like the oil giants, BP, IOCL, HP. These are all the companies, Maharatna companies. Among the 10 companies, Power Grid Corporation of India is one Maharatna company in our country. So as I told you, the main important purpose of Power Grid Corporation of India is to control the interstate power transfer. That is the objective. And regarding the Power Grid Corporation of India, this company is having business in 21 countries, not only in our country, but also in remaining 20 countries. So far, 21 countries, they are having business, and they are having international accreditation, that is Moody's accreditation, and national accreditation they are having. And the company, Power Grid Corporation of India, is on its own, it is having more than 265 substations. In any particular day in our country, in any particular day, whatever be the power generated in our country, 95% of the total power generated in this country will be somewhere handled or transmitted by Power Grid Corporation of India's transmission facility, because this company has more than 1,72,000 circuit kilometers. Solunga? Yeah.
Slide is not moving, sir. Slide is not.
Slide. No, I did not move the slide. It is available. In the first slide only. I am still in third slide only.
Okay, sir. Thank you, sir.
Yeah. I am in the third point, Power Grid Corporation of India, right? So still, this company is having more than 172,000 circuit kilometers of transmission facility, and more than 265 substation on its own. So not only the business is not only inside our country, apart from our country also we are having business. And this Power Grid Corporation of India only responsible for the that is the realization of the SAARC grid. Actually, we wanted to maintain a grid among the SAARC countries, right? Okay, so the SAARC countries grid establishment work, and then they are having a control over India, Nepal power grid maintenance, and India, Bangladesh power transfer maintenance, and recently the project which was planned for underground cable through the sea line from India to Colombo. Okay, all these projects are coming under the control of the Power Grid Corporation of India only. So this is the peculiar character of Power Grid Corporation of India. So single largest power transmission utility in our country. And I told you from December 31st onwards, we have only one frequency in our country, one nation, one grid, one frequency, that is called as. Okay. As far as power generation is considered, as far as power generation and power demand is considered in our country, in average 1.6% difference between power generation and power demand. So this was very huge some 10 years before, but now we have reduced the gap between power generation and power demand within 2%. This difference is, and moreover, among the total power generated in our country, 60% of the total power generated in our country will be from the fossil fuel based power generation facilities. Then 12% will be from hydro power generation facilities, and around 26.3% from renewable energy resources, including solar and wind, and the remaining 1.67%, okay, from nuclear power stations, roughly around 6,500 megawatt of installed capacity from nuclear power stations. So this is the division of different types of power generation facilities in our country, right? Then now, as far as power generation is considered, I told you fossil fuels are having a big say on the total power generation. 60% will be from the fossil fuel based power generation facilities, and coal based thermal power generating station is the dominating one in the fossil fuel based, apart from diesel power stations and other types of conventional power stations. Coal based thermal power generations are having a major role in the power generation. So the main important demerit of the coal based thermal power generating station is the emission of pollutants from the power stations, that is oxides of nitrogen, NOx, oxides of sulfur, then the mercury, fine particles, and the oxides of carbon. So mainly oxides of nitrogen, oxides of sulfur, oxides of carbon. These three are major pollutants emitted into the atmosphere from the thermal power generating stations. Okay, right. Now, a small history I want to say regarding this, that is emission pollutants emitted into the atmosphere. Till 1988, no worry about emission of pollutants into the atmosphere. No country worried about pollutants emitted into the atmosphere till 1988. In 1989 only, the United States of America, the first country who worried about the atmospheric pollution and global warming. Slowly, the awareness in the Western countries started from that particular year, 1989 onwards. They started worrying about the pollutants emitted into the atmosphere, and because of these pollutants emitted into the atmosphere, the atmospheric pollution and global warming, they were worried about. So, USA, the United States of America, first formulated an amendment called CAAA, Clean Air Act Amendments, in the year 1990. The main important objective of the CAAA in the year 1990 was to reduce the oxides of nitrogen, oxides of sulfur, oxides of carbon emitted into the atmosphere from different sectors. Automobile sector available, power sector available, so from different sector, industrial sector available. So from different sectors, how much pollution as on today, in 1990 I'm saying, as on 1990, how much pollution was caused by different sectors, and how the pollutants emitted into the atmosphere can be reduced. The remedial actions were also been proposed by the Clean Air Act amendments. But no country was stressed by USA to follow the Clean Air Act amendments. Anyway, it was when it was tabulated in UN, United Nations forum, then all the countries were understand the importance of that is reducing the pollutants emitted into the atmosphere. So the world was divided into two broad categories: developed nations and developing nations. So developed nations were talking about, because they were already developed, economically developed, they were worried about the pollution and global warming. The developing nation were already in the process of economic improvement, right? So they wanted to improve their economy. So in order to improve the economy, the backbone is electricity, industrial sector, and automobile sector. So no way they were worried about the pollution and that is global warming. So the countries which were called as developed countries, they arrayed themselves under USA, and the developing countries were arrayed in a new protocol called Kyoto Protocol. Okay, so broadly speaking, Kyoto Protocol is the protocol which was originally proposed by India and China, the two major populated countries in the world. And Kyoto Protocol is different, Clean Air Act amendments is different. In order to understand the difference, Kyoto Protocol will give more relaxation for the developing countries, whereas the Clean Air Act amendments will be giving uniform amendments, that is uniform rules and regulations for the member countries. This is the difference. Okay, so the developing countries were under the umbrella of Kyoto Protocol, and in 1996, in the place Kyoto in Japan, they have formulated the protocol, and that is why it is called Kyoto Protocol. It was implemented from the year 1997, and India is one of the signatories in the Kyoto Protocol. And the main important objective of the Kyoto Protocol is for reducing the greenhouse gases which were emitted into the atmosphere from different sectors. Okay, that is the main objective, right? And many countries like Canada, Germany, Russia, all were once part of the Kyoto Protocol. Then once the Kyoto Protocol was come into action from 1997 to 2006 first phase, 2006 to 2016 second phase, and subsequent phases are coming. When the Kyoto Protocol was implemented, many countries withdraw their membership from the Kyoto Protocol due to the due to the relaxations given to the developing nations like India, right? So main objective is we want to control the pollutants emitted into the atmosphere. And COP meetings, you should understand next. COP, Conference of the Parties. Okay, the Conference of the Parties means the countries which were available on this globe. Okay, around 196 countries were signatories in the Conference of the Parties meeting 21. COP 21 means 21st meeting held under the heading Conference of the Parties in the place Paris. Okay, and in November, December 2015, it was held in Paris, and it is called, otherwise called COP 21, otherwise called Paris Climate Accord, and India and America, all the giants were signatories in the Paris Climate Accord. And after Donald Trump was president of USA, they actually withdrawn from COP. That is a different story. The main objective of COP 21 is stressing the more populated countries to follow the emission norms very strictly. That is the main objective. So 2 countries, if you omit, then no climate accord will be realizable in the world. The countries are China and India, right? So Paris Climate Accord was attended by our Honorable Prime Minister of India, Sri Narendra Modi ji, and we are the signatory in the COP 21. And the latest COP held was COP 26, which was held in Glasgow, Scotland. Okay, so last year it was held in the month November 2021, and they were discussed about the how the project, that is the climate accord, was implemented, and what are the actions taken by the developing countries like our country. And we were our representatives were presented how we are slowly moving towards electrical vehicles. Okay, green energy technology, how we are closely moving. So that was presented and it was going on. COP 27 will be held in this year, November. Likewise, the COPs will be held every year. And COP and CMP. CMP means it is related to Kyoto Protocol. COP 21 is CMP 11 in that is Kyoto Protocol related. So COP 21 Paris Climate Accord amendments are nothing but CMP 11 Kyoto Protocol Accord, and we are following. All the countries are following, and they are slowly moving towards the green energy. That is why we are stressed to abandon the fossil fuel based 4-wheelers and 2-wheelers, and we are moving towards the green energy vehicles, electrical vehicles. Okay, so that is the reason we are moving towards electrical vehicles. And non-conventional energy sources, you know very well, wind, solar, tidal are nowadays we are having very high boost on wind, solar, tidal related power generation facilities, and hybrid wind, solar power generation facilities, etc. We are concentrating slowly on wind, solar and tidal power generation facilities. Originally, these wind, solar, tidal power generation, smart grid power projects in our country, okay, all are possible only because of the already completed task called power system restructuring and deregulation. Whenever restructuring and deregulation was completed, then only the power sector can be treated as a business oriented sector. Otherwise, it is called service oriented sector. What do you mean by service oriented sector? The main objective is we want to serve for the people. For example, health sector. Okay, if government hospitals are available, the purpose of government hospital is not to make profit, but to serve for the people of the particular territory. Likewise, in order to make the power system sector a business oriented sector, the first country which was done restructuring and deregulation is Chile. Okay, the South American country in 1979, they have treated this as business. It is not a service oriented commodity. Electricity is no longer service oriented commodity. It is a business oriented commodity. Whoever wants, they can purchase it. That is the concept behind restructuring and deregulation. Our country successfully started restructuring in the year be completed and deregulation. What do you mean by sharing? The sector will be divided into, the power sector was divided into generation, transmission, distribution. Okay. What do you mean by deregulation? Once the restructuring is done, then whoever the business organizations wanted to do their business in any of the sector, generation, transmission, or distribution, they can come and do their business. They can start their generating station like Tata Power, okay, Reliance Power, okay, in generating station. Otherwise, they can start their own, they can construct their own transmission facility like the one which was available in Chennai, GRT Power Private Limited, okay. The company has on its own many hundred kilometers of transmission facilities in Madhya Pradesh. Likewise, whoever wants to do their business in the power system sector, they can select the sector, whether they can do it in generation or transmission or distribution. Okay. So, in this, related to this restructuring and deregulation, I want to give you a very small personal experience. Okay. When we visited South Westphalia University in Germany, it was actually located in the state North Rhine, South Westphalia. That is the area where this university was located. And myself, myself and Dr. Jeevanandan, my colleague, we visited South Westphalia University in Germany, and it was located, one part of the university was located in Soest, the place called Soest. There, hardly around 2 lakh people were living in and around Soest, but the electricity purchase is very interesting. They are having so many distribution companies, DISCOMs, distribution companies available in the small place called Soest. Before 3 months, they are floating the, that is offers, okay. If you want to get, suppose if we are in March, if anybody wants to purchase electricity from a particular DISCOM for the month of April, May, June, then they will give any one of the tariff. So they have different options. One type of tariff will be flat rate tariff. Okay, you will be charged whatever be the power consumption, you will be charged at a flat rate of this much, that is 0.15 euro per unit. Just like they will float advertisements. Block rate tariff also available. If within 100 units, if you consume, the rate will be 0.05 euro per unit. Then if from 100 to 200, we are having 0.15 euro per unit. Then beyond 200 up to 500, it is 1 euro per unit. Likewise, the rate will be different for different blocks. So this is one company's offer. Likewise, around 3-4 companies are available. Distribution companies are available. So like other commodities, if you want to purchase vegetables or groceries, you will go where the quality is good, where the quantity is correct, where the cost is cheaper, you will select a shop. Whether is it possible in our area nowadays to purchase electricity in the same way? In the same way, we are purchasing mobile phone connectivity from Vodafone or from BSNL or from Jio. You are having multiple options, but you are not having options as far as electricity is considered. So electricity sector also, even 10-11 years before, in that particular place, the people of that Soest place, they had the opportunity to purchase power from any of the supplier. One another fact is, one company is giving, during our visit, one company is saying, if you purchase electricity from our company, they are giving one more offer. Like if you purchase one saree free. Likewise, some offers you will experience in the textile showrooms, right? Likewise, they are giving, if you purchase electricity from us, we will pay your landline bill for first 100 units. So first 100 calls will be paid by the power company, which is originally slotted for giving electricity to the consumer. Likewise, the people are doing business in the distribution sector also. These are all possible only because of the power system restructuring and deregulation. Only difference in our country is, in our country, we are having states and union territories. All the states and union territories are having their own state electricity boards. All the state electricity boards almost are running in deficit of money. Okay, because of the some free schemes they are announcing, some free that is power they are giving. Okay, so but the truth is power cannot be generated at a free of cost. Anyway, you have to invest some money and you have to that is get back the money. That is called a payback period. Then only you can do that is again reconstruct the power plant after 30 or 40 years of its lifespan. So power system restructuring and deregulation was a complicated process in our country because power is not only the central's control, but also state is having a control over the electricity distribution in a particular state. Because of their economic status, it was very difficult. At last, we are achieved. All the state electricity boards were understand the importance of restructuring and deregulation, and they completed. And the final point in the introduction is smart grid projects in our country. Okay, originally many smart grid projects were proposed by Power Grid Corporation of India, but a very good, very successful smart grid project was implemented in the Union Territory of Puducherry. I am very proud to say we are having a very successful smart grid project in our territory, Union Territory, and Puducherry smart grid project, it is otherwise called as. The Power Grid Corporation of India is enabling the implementation of the smart grid project in Puducherry. The main objective of smart grid, what do you mean by smart grid? You know very well. Smart grid means the IQ level of the grid was improved. Actually, conventional grid is one-way communication. Power will be moving from the source to the destination. Okay, source to the consumer's premises. But here in smart grid, simply speaking, two-way communication possible. Okay, so power and also the communication signal can be passed from source to destination. At the same time, if the consumer wants to communicate with the source, they can communicate back through the same line to the control center of the smart grid project. So smart grid project was successfully implemented here. In the smart grid project, we are having phase 1, phase 2, phase 3. At present, what we completed is in a particular locality of Puducherry, Union Territory of Puducherry, that is the place called New Saram. We have successfully replaced the conventional energy meter by smart meters. We have replaced the conventional energy meters by smart meters. The purpose of smart meter is in order to accurately measure the consumption. Number one. Number two, in order to 100% tamper-free, tamper-proof meter, providing tamper-proof meter to the consumer. Number three, if any power theft in any of the place in between the nearby pole and the consumer premises, it will be automatically indicated by the smart meter. And these are some of the important features available in the smart meter. Okay, then they are giving the smart meters are coming from countries like China and other European countries, and they are issuing smart meters. And we are having a smart grid that is monitoring center in the place called Venkatanagar. There we are having a monitoring station. From that monitoring station, any consumer can be watched. Okay, we visited 2-3 times there, and in that particular locality, New Saram, where the smart meters were given, the control center people, they are simply seeing each and every consumer's consumption pattern. At present, how much power is consumed by the consumer. Okay, that is in which, who are all the consumers, their door is closed. That can also be read. Okay, it is sometimes against the privacy. Okay, so that side we should not go. The advantage is, so how much power going from this side to that side, that can be from the distribution transformer, how much power is available to the consumer, how much power is consumed by the consumer. So between primary supply and the secondary side load, that can be measured very easily and through the smart grid project. Okay, smart grid monitoring center. And in the smart grid monitoring center, everything is going that is in a software, right? They are giving bills in the electronic mode, and they are paying back with the help of the cards. Okay, debit card and Jeep, that is UPI pay methods. They are paying back the energy bills. Okay, so many advantages available. No need of any person going to the nearby substation or nearby distribution station to register their complaint. Nothing is required. Everything is understood by the monitoring center, and they will send the maintenance people immediately to the. Okay, so the main objective is we wanted to have a renewable energy integrated smart grid project in Puducherry. Renewable energy integrated smart grid project in Puducherry, and we are slowly moving towards the objective, right? That is the status of the smart grid project in Puducherry. And as far as power system components are considered, you know very well, power generation, transmission and distribution. Generation station, transmission side, you are having primary transmission and secondary transmission. In distribution, you are having primary distribution and secondary distribution. So, these are the main important organs of the power system: generation, transmission and distribution. And by analogy can be established between a power system and a human body. Analogy can be established between a power system and a human body. Okay, right. Now, for example, you know very well generation available, that is RLDC, SLDC, RLDC and NLDC available. What do you mean by SLDC? State Load Dispatch Center. So Tamil Nadu, it is having its SLDC in Chennai. Puducherry, we are having SLDC in Puducherry, because Puducherry is having 4 important regions. Okay, that is disintegrated regions. Okay, so we are integrating in the name of Puducherry all these 4 regions. Okay, Puducherry, Karaikal, Maghe and Yenam. These 4 regions are coming under the common umbrella Union Territory of Puducherry. So these are all the remaining 3 places are our places only. Union Territory of Puducherry's places only, but they are located in different parts. Maghe is in near Calicut, in Kerala, near Kerala. Maghe is near Calicut, Kerala. And Yenam, you know very well, it is nearby to Kakinada and Andhra. Okay. Then Karaikal is the place which is available 160 kilometers away from that mainland Puducherry, near Thiruvarur, the district Thiruvarur. So 4 different parts of Puducherry are available and in 4 different locations, and all the 4 regions will be combinedly called Union Territory of Puducherry, and we are having our own SLDC. Okay, in SLDC, like SLDC setup in our Union Territory of Puducherry in Puducherry region. Okay, and we can you can visit at any time, and in different parts of the Union Territory of Puducherry, how much power is going and what are the transmission line as on time, in online, in offline, everything can be read from the SLDC. RLDC means it is like a brain for a human. Okay, RLDC means Regional Load Dispatch Center. For example, our southern regional for southern regional grid station, we are having RLDC in Bengaluru. Okay, near SLDC Bengaluru, RLDC Bengaluru is available. RLDC there I visited 2 times RLDC in Bengaluru, and in RLDC we can see what are the power interstate power transfer in southern regional grid between Andhra and Tamil Nadu, between Karnataka and Andhra. Likewise, any interstate power transfer and also intrastate power transfer inside the Tamil Nadu. What are the power transfer between? What is the power transfer status between two different districts? That can also be read from the RLDC. Okay, like SLDC. So enabled version of SLDC by including all the member states in the monitor, it is called RLDC. And RLDC is equal to our, by analogy, equal to the brain of human body. And the generation facilities are like the heart. Okay, once the heart stops, the man collapses. Likewise, if generation stops, everything will be collapsed. No meaning for the grid. Okay, power grid, no meaning. If no generation is available, so it is related to heart. Generation is. Then the sub transmission will be called sub arteries in our human body, and the main arteries are transmission lines. Main arteries are transmission lines, and the sub arteries are sub transmission lines, and the capillaries will be called by analogy equal to the distribution lines available in the power system sector, right? Okay. Now the human body, I told you already, human body power system analogy. Okay. In human body, blood pressure, you know very well, you will say diastolic and systolic as 80, 120. Likewise, power system will also have a parameter like blood pressure in human body. It is called voltage. Okay. So the heartbeat will be by analogy equal to the frequency in the power system. And already we maintained the, we are saying the pulse rate for human body 70 to 75. Likewise, the 50 cycles per second from 49.5 to 50.5 tolerance, we can say for frequency, right? Then what is the cause for the mismatch, or what is the cause for the collapse, or what is the cause for the heartbeat deviation? Stress and anxiety, you know very well. Okay, due to stress nowadays we are getting many diseases. Likewise, the load generation mismatch will be the main cause for the frequency deviation. So these are all the main important things you already understand related to the power and human body analogy. Now come to the peculiarities of the regional grids in our country. So these are the 5 regional grids which were shown here in this slide number 8, and the southern, northern, western, eastern and northeastern grids are shown here. And as far as northeast region is considered, it is very low in load. Normally the load will be very less in the northeastern state, but the northeastern states are having very high potential for hydropower generation. The only important problem is, if you have more and more power generation facilities, the power evacuation from northeastern regional grid to eastern regional grid will be a problem, right? That is the important bottleneck in the that is evacuation of power from NE to E region. Okay, right. Now southern regional grid is normally characterized by high load. Normally load will be very high in southern regional grid, but power generation will be very nominal. And most of the hydroelectric power generating stations available in the southern regional grid will be monsoon dependent hydroelectric power generating stations. If you go to the western regional grid, the western regional grid is very rich in industrial and agricultural load. Normally industry and agricultural load will be very rich in the western region. But as far as power generation is considered, it is nominal only here. Now, if you go to the northern region, it is called deficit region, otherwise called as. Even compared to southern region, the northern region is called deficit region, and it is highly weather sensitive loads available in this part, because Himachal available, Uttarakhand available, and Jammu and Kashmir. All these extreme weather condition states are available in this northern regional grid only. And so adverse weather conditions will be available, and highly weather sensitive loads will be available here in northern regional grid. So when before integration, one nation, one grid, one frequency was coming, power will be always flowing from western, eastern and northeastern grid to northern regional grid. That was the scenario before 2013. Now, because of the Raichur Cholapur HVDC bipolar link, now we have completely covered connected the southern regional grid with the rest of the system. So we have realized the one nation, one frequency, one grid concept. Okay, right. So normally the northern region and the southern region are called deficit region, western region to some extent. Okay, surplus regions are strictly speaking eastern regional grid and northeast regional grid. Okay, right. Now, as far as the hierarchy of Indian power system is considered, national grid, regional grid, state utilities. Okay, that is SLDCs. Okay, so national grid only one national grid, so one load dispatch center, NLDC. Regional grids are 5. That is why we are having 5 regional load dispatch centers. State utilities are available in 33 numbers. So we are having almost 33 SLDCs in our country. Okay, Right. Now, these are the players in the power sector. Okay, the main important players are generators. So generators are normally central or state-owned generation facility. For example, NLC, Naval Liquid Corporation, will be a centrally funded organization, autonomous body for power generation. Whereas if you consider Tuticorin Thermal Power TTPS, Tuticorin Thermal Power Station or Mettur Thermal Power Station, it will be state-owned, Tamil Nadu state-owned. Likewise, PPCL, Puducherry Power Corporation Limited, gas power plant in Karaikal, the place Karaikal, for a total installed capacity of 22 megawatt. It is completely owned by government of Puducherry. Likewise, state-owned, central-owned generation companies, it is called GENCO. Generation companies are available. IPP is available. IPP means independent power producers. The Reliance Power, Tata Power will be called IPP, a typical IPPs. They are called a typical IPPs, independent power producers. Okay. So what do you mean by CTU? Central Transmission Utility. It will be interstate transmission utility, and sometimes intrastate transmission utilities will be also available. That will come under STU. Okay. Okay. So state transmission utility. Then DISCOMs, distribution companies are available, and the main important purpose of distribution company is to purchase electricity from transmission companies at a generation companies at a bulk quantity and selling it to the consumers. Okay, that is the role of distribution companies. And at last, the consumers are available. The consumers are that is industrial consumer, domestic consumer, or commercial consumer. Okay, any one type. So these are the important players available in the power sector. Okay, so yeah, this is the one which I already told you. The grid management will be done by the this hierarchy. Okay, NLDC ensure integrated operation of the national grid in our country. RLDC ensure integrated operation of the regional grid. Okay, so the 5 member states are, for example, some 4 member states are available, means among the 4 member states, the coordination will be maintained by RLDC. SLDC means within the state, how the power can be distributed. That is the role of SLDCs, right? Okay. Now, this is the deregulation, which I told you already. That is unbundling of the entire vertically integrated electricity market into generation, transmission, and distribution. That is called unbundling the process, otherwise called deregulation. Okay, otherwise called deregulation. And moreover, yeah. Moreover, I told you already that the deregulation is very important, because by doing deregulation only, we can allow any member who wants to do their business in any of the sector, generation, transmission, or distribution. And if you come to the that is next slide. Okay, that is yeah. Restructured market architecture. So one side we are having GENCOs, generation company 1, generation company 2, generation company 3, etc., etc. And another side we are having DISCOs, distribution company 1, distribution company 2, etc., etc. So they are, the GENCOs are otherwise called as wholesale seller, because if anybody, a mediator or middleman who purchase in a bulk quantity, if they purchase all the power from generation company, he will be called wholesale seller, because after purchasing the power, anyway he has to sell it to the customer, okay, or distribution company. So one side suppliers will be available, one side purchaser will be available. Suppliers are otherwise called as wholesale seller, purchasers are otherwise called as wholesale customer or retailer. So the main purpose of wholesale customer or retailer is they will purchase electricity. After purchasing electricity from wholesale seller through ISO, independent system operator, they will sell their power to the end consumer. That is the objective of purchasing bulk electricity from wholesale seller by the wholesale customer or retailer. Okay, right. So this transaction between generation company and distribution company through ISO will be completed by a transmission company. Say, for example, if Reliance Power is generating electricity in the outskirts of Mumbai, they will be called a generation company. Suppose if Tamil Nadu Distribution Company, TANGETCO, Tamil Nadu Generation and Distribution Company, TANGETCO, a government organization, wanted to purchase the power from Reliance Corporation, Reliance Power, what they will do is, after the bids were finalized by the middle policeman called independent system operator, they will snatch the deal. They will sign the deal for the transaction. That transaction deal finalized can be implemented only by Power Grid Corporation of India in our country, strictly speaking, because 95% of the total power generated wherever it is in India, okay, it will be almost handled by Power Grid Corporation of India's generation facility, the distribution, transmission facilities. Okay, this I told. So the key market entities in the deregulated power market are independent system operator, generation companies, transcos, discos, retailcos, aggregator, broker, marketer, and customers. Okay, these are the people available, the different members available in the restructured electricity market. Okay, now come to the power scenario in Tamil Nadu. Installed generation capacity is 31,900 megawatt as on December 2021, and it has almost 10% of the total installed capacity of India is available in Tamil Nadu. And among the 31,900 megawatt of installed capacity, 44% of this 31,900 megawatt will be renewable energy resource based power generation facilities. Average availability of power in a particular day in Tamil Nadu is 13,250 megawatt to 13,750 megawatt. But average demand ranges from 14,500 megawatt to 15,500 megawatt. So we are having a shortage, slight shortage of electricity. That shortage will be met out by power purchase from private sectors, and taking control measures, they can do it. Normally, before Tamil Nadu Electricity Board was restructured, so it was one single entity. It is called Vertically Integrated Electricity Market. Now, after restructuring, the Tamil Nadu Electricity Board was disintegrated into three entities. TNEB Limited, first one, it is for organization, administration purpose, TNEB Limited. TANGETCO, Tamil Nadu Generation and Distribution Company. TANTRANSCO, Tamil Nadu Transmission Company. These are the three entities which were derived from Tamil Nadu Electricity Board. So the institutional structure of power sector in Tamil Nadu is shown here. This is what I told. So generation, transmission, distribution, and regulatory body. 4 divisions were made. The regulatory body was nothing but Tamil Nadu Electricity Regulatory Commission, TNERC. And then generation taken care of by TANGETCO, distribution taken care of by TANGETCO, and transmission taken care of by Tamil Nadu Transmission Company, TANTRANSCO, right? Okay. Now, almost the first part is over. Okay. The second part is now, what do you mean by power system planning? Why power system planning is necessary as far as a smooth power system operation is considered? Okay. These are the things to be studied in the next half of the presentation. Actually, the power, I told you already, there are 2 broad categories of power markets available. Vertically integrated electricity market, where there is no deregulation or restructuring. Okay, single entity, Tamil Nadu Electricity Board, Puducherry Power Corporation, Puducherry Electricity Department. So if no division, no restructuring and deregulation was done, that is called vertically integrated utility or electricity market. The major elements are in this vertically integrated electricity market. The power delivery chain will have major elements as long-term planning, short-term planning, mid-term planning. What do you mean by long-term planning? Infrastructure additions are coming under long-term planning. What do you mean by infrastructure addition? If the state is constructing a new power plant, it is called infrastructure addition. If the state is constructing a new transmission facility, that is called long-term planning, that is infrastructure addition. What do you mean by short-term planning? Day-ahead scheduling and real-time grid management. How the day-ahead scheduling will be done? Unit commitment. Okay, so if suppose there is surplus of electricity is generated, then this day-ahead scheduling is required. If more shortage of electricity also, day-ahead scheduling is very important. Then only we can understand how much power we have to purchase to meet out the load and where the load shedding should be done to meet out the real power, to meet the real power management in a smoother way. So day-ahead scheduling is very important. It is coming under short-term planning, and it is otherwise called as real-time grid management. Okay, what do you mean by real-time grid management? Through the SCADA systems, we can do real-time grid management. Okay, so wherever surplus of electricity, wherever shortage of electricity, that power diversion can also be possible only with the help of the short-term planning. What is mid-term planning in vertically integrated utility? Load and supply management. Okay, mid-term planning is load and supply management. Okay, so how much load is available, how much supply is available, and what is the criteria to be followed to meet the load supply balance. Okay, that is comes under the category of mid-term planning. So long-term planning, infrastructure addition; short-term planning, day-ahead scheduling and real-time grid management. Mid-term planning means load and supply management. This is the power delivery chain important elements in a vertically integrated electricity market. Now come to the power delivery chain important elements in the restructured electricity market. Now the name itself slightly changed, because in the restructured market, the purpose of investment in any sector by a private investor is they wanted to make money. They wanted to make profit from the business. That is the objective. If you start any business, your objective will be making profit, not serving for the people, not only for serving the people, but also for making profit from the business. So the major elements are slightly changed compared to the power delivery chain in the vertically integrated electricity market. It is called long-term planning, not only called long-term planning and investment analysis. Suppose if any private party constructing their own transmission facility or generation facility, they will do all the n number of calculations. Okay, so how much power will be generated, how much money will be invested, what is the bank interest of the investment, what is the interest and depreciation of the power plant, and how it can be in equivalence converted to money. Everything comes under the investment analysis. So they will do long-term planning along with investment analysis. They will calculate the payback period. In how many years the invested money will come back, and afterwards how much money can be gained for how many years. That and all comes under investment analysis. It is combinedly called infrastructure addition in restructured electricity market. Short-term planning, it is not only short-term planning, it is otherwise called and asset management. What they are doing, the same duties, day-ahead scheduling and real-time grid management. What do you mean by day-ahead scheduling? Suppose during the there is a lockdown period, we understand it very easily. When the continuous lockdown was implemented in the month March 2020, we understand this. Okay, yeah, very easily we understand this. When the complete lockdown was followed in our country, all the industries were closed. All the industries, commercial establishments were closed. Only consumers are the very essential industries running and the corresponding consumption, and the commercial places like the government offices and important offices and the domestic consumers. So all of a sudden, the demand was drastically reduced during the lockdown period, pandemic period. So what the private power, that is IPPs, independent power producers have done, they have completely closed the power stations. What is the reason? The reason is they have done the process asset management. If they run the power plant and generate electricity and nobody is ready to purchase electricity, then it is a waste. So they understand, and because they've done asset management calculations, they have managed this day ahead scheduling and real-time grid management. And the last one is called midterm planning and risk management, combinedly called risk management. Okay, so midterm planning, load and supply management, it comes under midterm planning. Now we are joining one more word called risk management. Okay, so whenever load and supply management was done, okay, yeah, power plant may be sometimes forced to be switched on. Suppose if no profit is calculated by the asset management calculations, the independent IPP will not switch on. Under such circumstances, how the risk of grid failure can be managed properly, that will be done under midterm planning and risk management. Okay, right. Now come to the generators and load revisited, and I will take some water, and 1 minute give me a break, 1 or 2 minutes. I will take water and come. Okay.
Okay, sir.
Yeah. Yeah. Yeah, now I will continue. Yeah, sir, the generators and the load, you right from generator we have to start because generators are generating electricity. The generators are creating potential, okay, that results from changing magnetic field. You understand about generator principle of operation, that is not our objective. So suppose if you are having a single set of poles, it must rotate at 50 spins per cycle to generate 50 hertz electricity. That is the generator I am saying. The generator, it has to rotate at 50 spins per cycle if it wants to generate electricity at 50 hertz with the help of a single set of poles in a generator. Load will be having several requirements. The load means the different types of loads. It will be having several requirements. It is frequency requirement, sometimes accurate frequency requirement, voltage requirement, real power and reactive power requirements are available. Real power is the power consumed by the resistor. Strictly speaking, real power is the power consumed by the resistors. Reactive power is the power that oscillates between the components of an electrical system. Now, as far as the load requirements are considered, main important requirements are frequency, voltage, real power and reactive power. Because of this requirement only, in real-time power system operation, we are having two important loops: real power frequency loop, reactive power voltage profile loop. Two different loops are available: PF loop, QV loop. Whenever there is an imbalance between real power generation and real power demand, the frequency will be affected. It will either go up or come down, depends upon the conditions, whether real power generation is high or low. In a similar fashion, whenever reactive power generation not matching with reactive power demand, then the voltage profile will either go up or come down. That you understand very clearly. Okay. Now, real power, it is very, very important. Many blackouts which were happened in the earth in the last in this last 2 decades are examples for real power, importance of real power. The first important blackout I want to discuss is in the year 2012, July 30, July 31st, which was happened in our country. In July 30, around 35 crores of people were affected. In July 31st blackout 2012, around 65 crores of people were affected. If you see the reasons behind the blackout happened in the history of the entire world, the single largest blackout happened is July 31st, 2012 blackout happened in our country. If you see the reason behind this, the very important reason is the overloading of Agra-Gwalior 400 kV transmission line. It was originally designed for 2000 megawatt of evacuation, power evacuation facility. When you overload the Agra-Gwalior 400 kV line, it was forced to the out of state. Once a voltage, once a power transmission line is out of state, the entire bundle of 2000 megawatt was treated as real power loss at that particular instant of time. And immediately, if you lose this much quantum of electricity all of a sudden, no SCADA system or no real-time grid management system can manage this contingency at a quick operating time. Not at all possible. That is what happened on that particular day, which was called the major blackout in the history of world, which was happened on the day July 31st, 2012. Okay, now come that is the example. Again coming back to the normal state from blackout is a different, very difficult process, and it is a very critical process, and it will at least take 10 to 18 hours to come back to the normal state of operation. That you understand very well. As far as the real power is considered, I told you already, it is power consumed by the resistors. Strictly speaking, this is the definition. Resistor only can consume real power. We know very well. Then what do you mean by reactive power? We should understand reactive power. So reactive power is the enabling power which will enable the transfer of real power from source to destination. That you can say. Or otherwise, reactive power can be called as the power which oscillates between the components of an electrical system. We can say in this way also we can define. Okay. But energy is not consumed while providing reactive power. You understand first. Energy will not be consumed when you provide reactive power. Okay. In a power system. Now we should understand how you are saying, sir, energy is not consumed while providing reactive power. Very easily we can understand. A very common, there is, if you go to Google search and if you put reactive power search engine, reactive power, the word, then immediately a practical image will come. In that image, so the practical example, that is the practical daily life happening. If you pour or if you transfer the coffee between two different tumblers, in order to cool the coffee, a hot coffee, if you want to make it cool, you will transfer between two different tumblers continuously. At that time, the foam will be happening or gathering on the top layer of the coffee. Or otherwise, when we pour the, any other liquid, okay, for example, soft drinks. If you pour it in the tumbler, then what will happen? Your foam will be coming on the top layer. Now, you cannot avoid the formation of foam in these two processes. That you understand first. In a similar fashion, the reactive power consumption cannot be avoided in the power sector. Next one. If you drink the foam, when you pour cool the coffee, and after settling down in one tumbler, if you drink or if you consume the top layer of foam, what will happen is that cannot give any satisfaction to the person who drink that foam. I can 100% I can say it cannot give any satisfaction. The real satisfaction will come only when you drink the coffee which was actually available below the layer of foam. That foam is called reactive power. Energy is not consumed because the foam is not giving any satisfaction, like how the foam is not giving any satisfaction to the consumer. The energy will also be not consumed while providing reactive power to the electrical components. And grid devices such as generators, transmission lines, etc. must be able to manage the additional current flow. Always these devices should have the capability of managing additional current flow, because there is every possibility of increased current requirement in the power transmission facility, or due to the load requirement. Sometimes increased current requirement may also be happening at each and every instant. This is the requirement, this is the happening. So you have to make your transmission lines, generators and other terminal equipments be ready to manage the additional current flow. And the power and the energy cycles of inductors and capacitors, you know very well. No need of wasting the time in the power and energy cycles of the inductors and capacitors. These are the grid equipments we already come across. Generators, AGC, automatic generation control, AC transmission line, DC transmission line, converters, distribution lines, transformers, regulating transformers, circuit breakers, surge protection devices, and then surge protection devices, additional lightning protection, reactive power provider, station bus, distribution switches, SCADA and monitoring system, black start generator. These are all the important grid equipments available in any particular grid, power grid. Okay, these one or two may be absent, depends upon the requirement. One or few may be absent, but most of the things will be available in the grid. Okay, till black start generator. Right now, come to the first one, generator. What is the generator? What the generators are doing? Voltage maintenance, frequency regulation, real power generation, reactive power requirement satisfaction, and then within the power limit, it will be operated. So voltage can be maintained with the help of because that is why AGC that is automatic load frequency control, ALFC or AGC, AVR loops were discussed. Okay, and the purpose of AGC is to have a generation control, AGC, automatic generation control, and otherwise called automatic load frequency control. Okay, so frequency regulation also we are doing with the help of generator. Okay, then AVR, automatic voltage regulation. So voltage maintenance will come under that category. And in addition, it is providing reactive power, and within the minimum and the maximum generation capacity limits, the generator can be made to generate electricity. Automatic generation control, you know very well, AGC normally responds to fluctuating grid conditions. From where the fluctuations will come? From the generators, load and the transmission systems. Why the fluctuations are coming? If any one generator out of state, that is from generators. If any one transmission facility was failure, it is from transmission system. If any one bulk consuming that is bulk electricity consuming industry all of a sudden shut down, that is called fluctuation from load. So fluctuation will come from any side, either from generator or load or from transmission system. Load fluctuations normally happening due to consumer activity. You know very well. Even in your home, if you want, you will switch on the AC. If you don't want, you will switch off the AC. Whether you are informing it very clearly to the nearby substation or receiving station? No, not. So consumer activity is the reason for load fluctuation. But for generator fluctuation, it is not due to consumer activity. It is due to sudden outage of any generator fluctuation. Transmission fluctuation due to equipment tripping. For example, in a transmission line, during the stormy weather condition, any one nearby tree or branch of a tree falling, immediately the nearby relay and circuit breaker will be isolating that particular part from the transmission system fluctuation in a simple words. So example of sudden outage of any unit and AGC line, it will be due to that. Okay, right. One practical example we can give, that I want to remember here. Okay, right. In 2003, major blackout happened in US, United States of America, and part of Canada affected by this major blackout. What happened in the they have IEEE committee has been formulated to submit the report on this 2003 major blackout happened in US. The IEEE committee, they have given the reasons behind the blackout. The first and foremost important reason is that tree trimming was not done properly. Line from Ohio, the state Ohio, the tree trimming was not done properly in the transmission line. Because the tree trimming was not done properly, one particular tree during the stormy weather period, it touched that is transmission facility. Immediately, the nearby substation, which was this line was actually disintegrated or removed from the rest of the system. This line was actually a transmission facility from nearby power generation facility. So all of a sudden, a loss of generation facility happened. Because of that loss of generation facility, the nearby substation, all the substations were forced to out of state, and the entire that is one simple not proper tree trimming. Because of not done the proper tree trimming, the entire USA was coming under the out of state condition. And the question here is, what is the role of the supercomputers which were employed in the real-time grid management, and what is the role of the very superior software packages developed for the power sector of USA? That question were arised. Whatever be the supercomputer or whatever be the that is software package, intelligent software package developed by the that is developers, it could not manage the things if any major power generation facility was out of state all of a sudden. No software can give solution if it happened all of a sudden, the loss of one particular generation unit. Okay, that is what the practical example for sudden outage and what will happen at the time of sudden outage of any one generation facility or generating unit. Transmission outage reasons may be insufficient voltage support, system instability, violation of current limitations, insufficient ground clearance, contact with a tree, that just now I told, tower collapse, failure of supporting equipments, lightning strikes. These are all the reasons for transmission outages. But for avoiding some of the things in this list, we are having remedial actions. But anyway, okay, sometimes beyond the human control, some happenings will be, so transmission outages are happening. What are all the reactive power providers in the grid system? Generators can provide reactive power, capacitors, inductors, static var compensator, static synchronous compensator, servo mechanical compensator. Sir, inductor, how it can be called as reactive power provider? The question will come. Whenever reactive power management is done by inductor, it can be done. Reactive power management can be done, okay, with the help of inductors. Okay, if leading power factor loads are available. Under such circumstances, the inductors can be used to absorb the that is excessive reactive power supply by the leading power factor, because leading power factor load availability. That can be, so reactive power management, we can use inductor. So servo mechanical compensators will also come under the category of reactive power provider. What do you mean by black start generator? Black start generator means at the time of the grid failure, all the power generation facilities will be out of state. So no power, virtually no power in the grid system. At that particular instant of time, the resynchronization starts with the black start generator only. A diesel generator with a battery pack will be normally used as black start generator. This black start generator will start working and generate electricity at a smaller quantity. Then it will be used to start the process of resynchronization, and one by one the power generation facilities will be resynchronized step by step, and step by step addition of load will be done. At last we can realize the resynchronization 100% successful. Now come to the grid reliability and grid contingency requirement. Normally for the next day schedule, that is for unit operations, the generation facilities operations, the advance plan will be made. Okay, right. Nowadays, not only power purchase, but also people are very much interested in ancillary services. What do you mean by ancillary services? I not only want power at a particular quantity, I want power at a particular quality also. If you are putting power quality constraint in the power purchase, the consumer I am saying, the consumer or bulk purchaser I am saying, if you put a condition not only for quantity of electricity but also for quality of electricity, that is called ancillary services. So what are the ancillary services we know? For example, power quality. So I want this much THT, this much voltage regulation in my electricity. This much voltage deviation only should be allowed. Likewise, you can put n number of ancillary service requirements. Other service requirements will be, ancillary service will be uninterruptible power supply. At any cost, I need 24 hours uninterruptible power supply. Suppose if I am conducting a national level exam, for example, NEET, or for example, through online, we are conducting JEE, okay, at a particular slot from morning 10 o'clock to afternoon 1 o'clock. So I want to maintain electricity in almost all the that is areas where the centers are available. That is called one ancillary service. If you want uninterruptible power supply during that particular duration, that is called ancillary services. And the most common failures involve transmission lines and generating unit outages. So if you require these ancillary services along with regular service, these most common failures should be properly managed. That proper management of the failure possibilities can be done only by contingency planning. What do you mean by contingency planning? Contingency planning, very simple. Okay, very simple. Suppose I am writing a 12th standard examination. I am putting n number of contingency. After writing a NEET exam, if I got more than 500 marks in NEET, I will join MBBS. I will write down JEE also. If I got more than a 95 percentile, I will opt any NIT. Suppose if my percentage is below 95, above 75, I will prefer PTU. Below 75, but above 50, I can opt for some other institutes. If not possible, below 50 means I will come to the state level admission process. In state level admission process, if I get this much aggregate, I will select this college. If beyond this much aggregate, if I get, I will select this group of colleges. If not, I will select a management quota seat in VR Siddhartha Engineering College. Likewise, I can put n number of contingency planning requirement for a power system operation. If any transmission line, this transmission line A failure, I will reroute the power to this location through this transmission line. So overloading can be managed to some extent by these provisions. Likewise, I have to plan n number of contingencies. And among the n contingencies, contingency ranking should be given by you. For a problem, you can have n number of contingency planning steps. But according to the rank, according to the preferences, you have to arrange the contingency planning categories one by one. Which one is more important? Place it at number 1. Which one is least important? Place it at number n. Okay. Likewise, you decide the order. So contingency planning along with its ranking should be provided by the power engineer. Okay. Now, normally the reserves will be used to tackle the failure of power generation facilities. The reserves are primarily categorized as primary reserves, secondary reserves, and additional reserves. What do you mean by primary reserve? Capacity of largest unit in the control area. What do you mean by secondary reserve? The reserve which can be available to meet the load within 30 to 60 minutes of switching on. What do you mean by additional reserve? 115% of the forecasted peak demand, if it is maintained in a readily manner, it is called additional reserve. Normally, primary reserve will be subdivided into 2 categories. Quick reserve like diesel units, spinning reserve like the units which will be spinning, which is in operation, but not supplying electricity to the grid system. That is called spinning reserve, hot reserve. Okay, hot reserve. It is already on state, but not supplying electricity to the supply system, right? That's all. That is called spinning reserve. Right. What do you mean by grid configuration? There are 5 functions that the grid can serve for the electrical sector. It can provide real power requirement. The grid can provide real power requirement. The grid can provide reactive power requirement. The grid can provide system control. In the control point of view, okay, we have to do control system aspect. We have to analyze the entire system, whether the system will be under the stable operation or not. That will be called system control. Ensure system reliability. What do you mean by system reliability? Suppose if power will be available for this particular hours of a day, every week in a year, then that should be happening. That is called reliability. If you say yes, you should fulfill the condition. If you say no, no problem, right? So you have to fulfill the expectations of the consumer, expectations of the different players in the power sector. That is called ensuring system reliability. System security, it is a separate voltage and security constraints we will be studying separately. So we have to ensure the system security also. These are all the 5 important functions the grid should serve, and the grid should be configured to provide these 5 important functions. Okay. So grid operations are normally contingency planning will be one of the grid operation that can be done. Okay. So under contingency planning, we can bring more units online to provide additional real power. So we can increase the import from nearby control areas to provide additional real power, and we can decrease the exports to provide more and more reactive power, and we can bring local units online to provide more reactive power, and interrupting the service of cheaper rate customers, and executing rotating blackouts. When we will normally execute rotating blackout? Suppose if power generation, the availability of power is very less or less compared to the power demand, we have to rotate a blackout between the different areas according to the economic ranking or industrial ranking. You can rotate the blackouts. Executing the geographically limited blackouts. Geographically limited blackout means, suppose if compared to Chennai and Kanjipuram, Chennai is more important. Okay, Kanjipuram is less important compared to Chennai. I am saying because Chennai is the capital of Tamil Nadu. So compared to Chennai, compared to Kanchipuram, the nearby place called the Tindivanam may be less important because Kanchipuram is the district headquarters, maybe. Okay. So likewise, n number of geographically limited blackout preferences can be executed by the contingency planning. Okay. Then monitoring is available, operations available. Under operations, okay, regulation. We have to maintain the regulation properly among the players in the power system, and the unit outages with moderate impact. Normally, what do you mean by unit outage with moderate impact? The units within the control area normally will be responding by increasing their output with the AGC. So imports from outside the control area automatically will be increased, okay, at the time of unit outage. Okay, capacitors and the other reactive devices respond for increased reactive power, and the control group informs the neighbor groups and reliability coordinator to coordinate the response. And in severe cases, control group may shed interruptible load and have a rotating blackout. Okay, the load shedding only called blackout here. Okay, both are synonymous terms. The control group may establish new set of primary and secondary reserves. Okay, so ACE automatic area control error is moderately outside its allowable limits. Okay, it can be moderately outside allowable limits at particular instant, and that should be properly monitored. Okay, and as far as this grid operations are considered, okay, sometimes a very small error by the control group, okay, or operator may leads to a major impact in the power system. Okay, one example for this is 3 Mile Island accident, which was happened in Pennsylvania state in USA. And in the year 1979, in Penn State, 3 Mile Island, island nearby to Pennsylvania state, and they are having a atomic power station. And in the atomic power station, all of a sudden, there was a blast happened, accident, nuclear reactor accident has happened. Okay, and when they inspected the causes of the nuclear accident and the reasons behind the nuclear accident, at last they find that one very small reason, that is one malfunctioning of the relays indicator. The indicator cost is hardly 1 rupee Indian money or 2 rupee Indian money. That indicator malfunctioned in the that is nuclear power reactor control system unit, and because it has malfunctioned, the operator, who was originally an expert did not analyze the malfunction properly, and he was allowed the valve to continuously open and ejaculate the water, okay, heavy water, which was nuclear, that is radioactive in nature, from the valve. Okay, so excessive emission, that is passage of heavy water from the nuclear reactor has happened because of the malfunction of one valve actuator indicator bulb. And that indicator bulb malfunction was, it can be understood by the operator, but unfortunately operator did not apply his mind, and it was leading to the major accident and leakage of huge quantum of heavy water. At last a blast was happened. Okay, and till today nobody reopened the 3 Mile Island the site, nuclear accident site, and afterwards no new nuclear power stations were constructed by United States of America after 1979. All are existing power stations only as on today, right? So the control group, the role of control group is very important. Their intelligence should be properly applied. Their expertise should be properly applied to assess the real-time happenings and the scenario, and accordingly they have to take the decisions. Okay, that is what the final topic in the presentation is: grid resilience. Okay, normally resilience means it is coming from the root word called resilio. Resilio means bouncing back, spring back or bouncing back. That is called resilio or resilience. So grid resilience or power system resilience means during the disturbance, how fast the system is coming back to the normal state of operation from the disturbance. That is what the word called grid resilience. Okay, so how much quickly and strongly the grid coming back to the normal state of operation, bouncing back to the normal state of operation, that is called grid resilience. Okay. Normally, power system resilience we are interested in. So some extreme events are happening all over the world due to the climatic changes like hurricanes and earthquakes. Earthquakes are very nature. Floods are due to climate change, we can say. And man-made attacks like the one happening in the that is Ukraine, Russia, that is cyber crime, that is cyber attack on the particular country. Okay, cyber attacks and physical attacks. Okay, these are all man-made attacks, which has increased dramatically in recent years. Yes, recently we are seeing all these in daily life. These events have severely impacted power system, ranging from long outage times to major equipment destruction. Okay, this calls for developing control and operation methods and the planning strategies to improve grid resilience against such events. So it is very clear that extreme weather events have significantly impacted the reliability and resilience of the power supply. Reliability and resilience are different from each other. Reliability means how much promise is fulfilled. The whatever that is 100% you are making promise means close to 100%. How much percentage you are fulfilling the promise? That is called reliability. Resilience means coming back to the normal state of operation from adverse conditions. The reasons for the adverse conditions already we discussed in the previous slide. Okay, these are the major blackouts happened and major destructions happened all over the world in the last 20 years. Okay, from the 2003 blackout onwards till 2019 Indonesia blackout, and what has happened and what is the reason behind this, and who are all involved and how much million of people were affected. Everything is available in this diagram. You go through it. Okay, right. These are the number of disaster events in the United States from 1980 to 2019 that exceed $1 billion in losses. Okay, they are categorizing the disaster events on the basis of billion dollar loss value. Based on the $1 billion loss value, they are categorizing this. Okay, so several definitions have been introduced for discussing about the power system resilience, and many definitions available. You go through it, you can understand this. And so the disturbance and dire curve is the curve which will be normally drawn for the evaluating the resilience of the power system. That is called the dire curve. Okay, dire means disturbance and impact resilience evaluation curve. Disturbance and impact resilience evaluation curve. Okay, any researcher now research papers are very less, even zero in this part of the country as far as power system resilience is considered. No papers available in this part of the country, but we are having greater scope in the power system resilience studies in this part of the country, because our country is vulnerable to many natural calamities, right? Under natural calamities, many blackouts have happened in southern regional grid or national grid. Okay, all those impacts can be properly studied by any researcher. Simply what they have to do is they have to take the data and they have to evaluate the dire curve, draw and evaluate the dire curve, and that will be a very good work. Okay, and common the terminologies and some benchmark terminologies are available as far as resilience is considered. That common terms are robustness, agility, adaptive capacity, adaptive insufficiency, resilience, and brittleness. Okay, all these common terms can be presented in the Dyer curve, and a typical Dyer curve is shown here. Disturbance and impact resilience evaluation curve is shown here, and which limit is called system agility, and which limit is called responder agility, and which is called resilience limit, and which is called brittleness limit. Everything is properly available in the curve, and if you go through it and you can understand. Along with this, I will pass one more IEEE paper in association with this, and you can understand the importance of resilience. So the metrics which are normally used in the resilience concept are load shedding investment cost, it for resourcefulness, restoration saving cost for rapid recovery, algebraic connectivity for robustness studies, and betweenness centrality for robustness studies, and adaptability percentage for adaptability. These are all the 5 important resilient metrics. They have to be evaluated by you if you take this topic for your research work. So for example, if you are taking a blackout condition, and if you are drawing a, not only blackout condition, you have to take a history of blackout happened in a particular period, and you have to draw the Dyer curve. From the Dyer curve, you have to evaluate these metrics. Okay. After evaluating these metrics, you have to come to the conclusion regarding the reliability. Okay. So the reliability based metrics continued as metric K, the first one. This is used to measure the expected number of lines outage due to destructive events. LOLP, loss of load probability, is used to measure the loss of load due to extreme event. Then expected demand not supplied, EDNS, is used to measure the expected demand not supplied due to extreme event. And A metric, metric G it is otherwise called as, that is used to measure the difficulty level of the grid recovery. Okay, these are all the important metrics which can be evaluated. Okay, so the one more diagram called conceptual resilience curve can also be drawn along with the Dyer curve, right? So the conceptual resilience curve has been developed to define and to quantify the power system resilience. Okay, it can quantify the power system resilience using conceptual resilience curve. Okay, it shows the level of resilience as a time dependent function with respect to the disaster event, as shown in the figure. Next figure, a set of metrics have been proposed which are abbreviated as FLEP, which stands for how fast, how low resilience drop in phase 1 disturbance progress, how extensive the post disturbance degraded state is in phase 2, and how promptly the network recovers in phase 3 restorative. These are all called FLEP. The set of metrics which are used are called FLEP. Okay, so the FLEP stands for this one: how fast, how extreme, how promptly. Okay, this one. Okay, right. So go through it and you can understand, right? This is the typical resilience curve, that is a conceptual resilience curve which can be drawn for a particular there is natural calamity or extreme event, and you can study it. Okay, so research gaps in resilience curves are given at last. Okay, so you can go through this research gaps available in the resilience studies, and resilience itself is completely absent in our country. Very minimal work is going on in this resilience, and you can go through it and you can understand what is the importance of resilience, power system resilience or grid resilience. Okay, right. So yeah, Muthukumar.
Yes, sir.
Yeah, Muthukumar, we can, shall we wind up? My throat is not cooperating with me.
Yes, sir. Yeah, we have seen that. Okay.
Any queries from audience they can ask. Huh?
Yes, sir. Participants, kindly, if you have any kind of queries, kindly, our Dr. M. Sudharan sir, professor, he is here. So can you please ask your queries one by one? Participants.
what I want to say is, if any smart grid related work you want to carry out, you can visit personally. You cannot ask data of the Puducherry smart grid system through email. That will not work out. You can visit the center, smart grid control center available in Venkatanagar in Puducherry, and you can understand a lot regarding the smart grid project implementation in Puducherry. You can understand, right? That opportunity is available here. And even yesterday, one college in Madurai, nearby to Madurai, they have approached smart grid center and they got permission. So you can, if any of the faculty members who wanted to visit with their students or with the faculty members, you can visit at any time.
Yes, sir. Yes, sir. Sir, one query is asked from the chat box. Please suggest a book, Power System Resilience.
Oh, just suggested book. No dedicated book available as on today for power system resilience. Okay, only IEEE survey papers and online materials are available for resilience, and you can very well understand from the resilience materials available online. Some Springer book chapters were available, but you have to pay and search and find out and get it. Okay, that is the option available.
Any other feedback from the participants? Any other feedback from the participants? Can you share anything? One participant asked your contact details.
Yeah, you can get it from Muthukumar. No problem. Muthukumar, you can give my number and email ID. No problem.
Okay, okay. Some people, they are saying in the chat box, valuable session. Thank you very much, Professor. Okay. Any other people open talk, you can ask. Otherwise, we can go to the final stage. Any participants? Shall we wind up? Okay, sir. Thank you, sir. Thank you so much for your valuable session, sir.
Thank you, Muthukumar. Thank
Okay.
you. All the very best. My heartfelt wishes for all the organizers and participants. My special thanks to Muthukumar and Mohan for introducing me to the crowd, right? Audience. Thank you very much. God bless you all. Thank you.
Thank you, sir. Thank you so much.